Okay, so the name of the chapter is volume and surface revolution. So first of all, we know already that if y equal to fx be a function, and if your function looks like this, then suppose this is the point x equal to, this is a straight line x equal to a, and this is a straight line x equal to b, and the area under this curve y equal to fx is given by the area, this is suppose a, area a is given by integration a to b, and the range is x, integration a to b, fx dx, fx dx. This is the area that you already know. Okay, now revolution, we will rotate some curve, and on the due to that rotation some surface will generate it, and we will calculate the volume and surface. First thing, let y equal to fx be a curve such that the curve is in both side, curve is in both side of x-axis. Our target is to find the volume of the solid being formed by revolution of the curve y equal to fx. Between x equal to x0 suppose, and x equal to x1. Okay, so let us draw the diagram. The diagram looks like this is x-axis, this is y-axis, and suppose it is your curve, and this is y equal to fx. Now just imagine that around x-axis, if you rotate the curve, so this is a three-dimensional figure will be generated. This curve, just rotate this curve maintaining x-axis as a center. If you rotate the curve, you will get a three-dimensional figure, something like cylinder. If the curve would have been straight line, then we can get a cylinder. Now that cylindrical type figure will be generated. I hope students can imagine that curve, if I rotate the curve and if I maintain the same distance from the x-axis, that is this distance are fixed, and if I rotate this curve like this, if I rotate this, I can generate a three-dimensional figure. The same thing happened this. So something like this three-dimensional figure will be generated, and our target is to find out the volume of this type of three-dimensional figure. So we will directly write the formula. First thing, if we rotate y equal to fx around x axis, we have a three-dimensional figure, something like cylindrical figure. And whenever we have a three-dimensional figure, we can have two things. One is surface area and other one is volume. So surface area is given by integration x equal to x0 to x equal to x1. So let me draw it. Suppose it is your x equal to x1, x equal to x0, and it is x equal to x1. Both are straight lines. So into 2 pi y times ds, elementary surface area. Or you can write this is equal to x0 to x1. 2 pi will be outside the integration, y times root over 1 plus y1.
Excuse me, sir.
Yeah,
Sir, can you repeat that previous slide once?
dx. Okay, and similarly volume will be, okay, let us focus on surface first of all. Okay, let me write volume. Volume will be pi times integration x0 to x1 x square dy, I guess. Pi r square is x square dy. No, it's just reverse. It's y square dx. Simple formula for volume, and this is surface. So based on these two formula, we will solve some problem. Suppose your question is like find the volume. Find the volume of the solid generated by revolving the parabola y square, sorry, x square equal to 4ay, where a is greater than 0, between the, it's called ordinates, not coordinates, ordinates. That is, we are going along y axis, y equal to 0 and y equal to a, about its axis. So for this kind of problem, diagram is mandatory. So first of all, draw the diagram. The diagram looks like x square equal to 4ay. All you should know that this will be the diagram. Okay, it has no end, now just rotate this portion of curve around this axis. Just rotate it, if I rotate this portion of curve, so something like a three-dimensional figure will be generated between.
Sir, excuse me, sir.
So once a surface has been generated, so just write that here Here x square equal to 4ay. This is actually x square equal to 4ay. So there is a difference between this problem and the thing that we have already discussed in the previous slide. That this is x-axis. We are moving. We are rotating the card around x-axis. Now here we are rotating the card around y-axis. So surface area and the volume, the formula for surface area and the volume will change slightly. Suppose volume will be pi integration the range of x. If you rotate around x-axis, it will be range of x, and it is y square dx. It is the formula if you rotate around x-axis, and if you rotate around y-axis, it will be pi, it is for y, and x square dy. Okay, now you can directly write volume of this three-dimensional surface. It is pi times the integration range of the integration has been given. It is y equal to 0 to y equal to a, and it is x square. Since we are rotating around y axis, so it is x square t y, and pi times 0 to a, x square is given, it is 4ay dy, and ultimately the answer is 2 pi a cube unit. Whenever the curve is possible to draw, then draw the curve. Whenever curve is completely unknown, do not draw the curve, but everywhere you can calculate. Suppose I'm doing another problem. Find the volume and surface area of x square by a square plus y square by b square equal to 1 about x axis. This is completely a shape like egg. So the curve looks like this, and if you rotate, this is as you know, this is 2a unit, and this is 2b unit, and it is your x square by a square plus y square by b square equal to 1. This axis has a name. It is called major axis, it is called minor axis. These things already you know from higher secondary. So I will go directly. This the coordinate is a comma 0, this is minus a comma 0, this is 0 comma b, this is 0 comma minus b, sorry, this is b comma 0 comma b, 0 comma minus b. Okay, right. Now if I move, find the volume solid formed by the rotation. So look at this question. Volume about x-axis. That means volume will be, so around x-axis. If we are rotating around x-axis, it will be pi times the range of x is minus a to a, x square, pi times it is y square dx, and y square you can put y square, that is pi times minus a to a, 1 minus y square is, just take y square from this equation. What is y square? 1 minus x square by a square into b square, I guess, dx. So you can easily find out the answer in terms of a and b. And of course, surface area you need to find out dy dx. So let me just take the next page. X square by a square plus y square by b square equal to 1, and surface area, the formula for surface area is equal to, if you know the formula of surface area, it is easy to calculate. It is 2 pi times x equal to minus a to a because if you just rotate this portion of the car, if you just rotate this portion of the car, this full volume, full three-dimensional figure can be generated. It's like egg. It's like egg. So this is equal to surface area will be 2 pi times y into root over of 1 plus y1 square dx. So from this equation, just make differentiation both side. 2x by a square plus 2y by b square into y1 equal to 0. So from that, y1 equal to 2x by a square by 2y by b square and minus, that is 2x by a square into b square by 2y. 2 to cancel, and y1 square will be, minus will be here, y1 square will be x square b to the power 4 divided by y square a to the power 4. So this is your y1. This is already you have y. The calculation will be little lengthy. Y will be 1 minus x square by a square root over of this into 1 by b. From this equation you can directly find out y. So the integration will be surface area will be 2 pi times minus a to a y root over 1 plus y1 square dx, that is 2 pi times minus a to a, it is 1 by b times root over 1 minus x square by a square into root over of 1 plus x square by x square b to the power 4 by y square a to the power 4 dx. It is not very easy to integrate, so this will be the answer. After, if you are not able to integrate, just leave it up to this step. This type of questions are very important for the exam. So let me solve another one. Find the volume of the solid obtained by revolving one arc of a cycloid x equal to a theta minus sine theta, y equal to a into 1 minus cos theta about x-axis. No problem. So we have the formula when we rotate the curve around x-axis. So just let me draw the diagram. What is actually cycloid? It is not mandatory to draw the diagram because we don't know what is cycloid. It is not mandatory to draw the diagram, but if your diagram is common, you need to draw the diagram. So here the diagram looks like the cycloid looks like this. So it is minus pi, it is minus 3 pi, it is pi, it is 3 pi, it is 0, it is x-axis, it is y-axis, and one arc. It means we can rotate from this portion to this portion, and you can see that if you generate if you rotate this portion of the curve, if you rotate this portion of the curve around x-axis, you can have a three-dimensional figure. Just fixing this axis up to from this to this, if you fix this line and if you just rotate this portion of the curve which is uh, marked here, this portion of the curve, if you rotate, you will have a three dimensional shaped body. So let me just it is the curve is x equal to a theta minus sine theta, y equal to a 1 minus cos theta. This is your curve. Okay, let us consider the arc from x equal to minus pi to x equal to pi, and let us rotate it about x axis. Okay, so the volume is v equal to, as you know, the formula is x equal to 0 minus pi to x equal to minus pi to pi, and pi is outside, y square dx, we already know that. So pi times x equal, so make it in terms of theta, y, we have the y, a times 1 minus cos theta into, so now I am making a dummy variable d theta, x is in terms of theta, d theta. So this is pi a, of course this is square, pi a cube into minus pi to pi, 1 minus cos theta just wait, I think I made a mistake. I think this was dx, this is dx, x was what, x was a into theta minus sine theta, so dx will be a into 1 minus cos theta, so it will be square into 1 minus cos theta again into d theta then. So pi a cube into minus pi to pi 1 minus cos theta whole cube d theta, and after that, okay, let me calculate it properly. This is equal to pi a cube minus pi to pi 1 minus cos theta whole cube d theta. Since 1 minus cos theta whole cube is an even function, this is equal to pi a cube, the 2 pi a cube 0 to pi 1 minus cos theta whole cube d theta. This is 2 pi a cube 0 to pi 1 minus cos theta is 2 sine square theta by 2 whole cube d theta. It is 2 pi a cube 0 to pi 2 to 8 into 2 16 into sine to the power 6 theta by 2 d theta. Let theta by 2 equal to z. This will be 32 pi a cube 0 to pi by 2 sine to the power 6 z dz. And this is very well known to us. This is, you can use reduction formula, you can use gamma function, beta function. Ultimately the answer will be 5 pi square aq. All you need to know how to simplify the problem, how to integrate. Integration is a strong tool, so you need to know how to integrate. Let us solve another problem like this. Find the volume of the solid. Find the volume of the solid obtained by revolving the cycloid x equal to a theta plus sine theta, y equal to, the problems look similar to the previous problem, a into 1 plus cos theta about its base. About its base means x axis. Sometimes it is written that about its base, that means x axis. So we will take a portion of the arc from minus pi to pi. It is similar to the previous problem. So I'm writing directly the answer, that volume is equal to required volume. You need to draw the diagram just like previous problem. It is pi times minus pi to pi y square dx. It is pi times minus pi to pi. Y means a into 1 plus cos theta whole square into dx. So differentiate both sides with respect to x. It is 1 plus cos theta a into d theta. So after all integration, the answer will be same as 5 pi square aq. Let me solve a problem which is similar to us. Okay. Suppose find the surface area generated by revolving about y-axis the part of the asteroid x equal to a cos q theta, y equal to a sin q theta in the first quadrant. This is a very important problem. So just I am writing the diagram, I am drawing the diagram. The asteroid looks like this is your asteroid. This is A unit, this is A, this is also A, this is A, and this is A. Okay, so first quadrant, that means this portion of the curve, this portion of the curve, this portion of the curve. If you rotate this portion of the curve around what? Around y-axis. So around y-axis, if you rotate this portion of the curve, if you rotate this portion of the curve, you will generate a surface. You will generate a surface. The surface will be three-dimensional surface, and the question is, you need to find out the surface area. You need to find out the surface area. So if you know the formula for surface area, this is the formula for surface area was
2 pi integration
yeah
x1
it is 2 pi times
x0 to x1 into
y into sorry x0 to x1 y
y
times
into z to
1
1 plus
plus
y
dy
square.
whole square dx. Okay, so this can be written as 2 pi times, you can see that this equation has been given parametric equation. So okay, no problem, we can do it. So take the equation x equal to y equal to, so x equal to